So file processing pipeline, right? We need to talk about how our static analysis engine sees files. How does it analyze them? There's a couple different steps we do, and we want to go through all of them. Before we even start processing files, we need to acquire them, right? So that's the first step, right? Getting the files. And that's the idea behind that is to understand where these files come from in the first place, right? And there's many different ingestion points we have, and those can be both the network. You can have the files on the network, you can have files on the storage. You can have files in the email, right? And, more recently, you can even talk about software as that data acquisition point where these files actually come from. Software specifically, like if an organization is producing software and is publishing software, ultimately that software package is something which needs to be checked alongside all the emails the organization receives and all the files it has on the storage and all the files it exchanges. Not to forget the endpoint, right? So all the files on the computers it actually possesses, right? So all of those are just ingestion points. And for us, we look at each and every one of these types of data sources individually. We create data connectors to our platform, and they're really, off-the-shelf, ready-to-use integrations, which plug into these existing solutions and collect the data for our platform. So we start with that predisposition. We have the file. So once we have the file, what do we do with it, right? So the next step is to identify. Actually, to understand what the file format is. There's about 4,000 different file formats we can identify today. More than 400 of those we can additionally extract and analyze in later steps. But to know what the file format is, we have two choices. One is signatures, and the other is machine learning. So SIGs and ML. Where do these apply, right? So if the file we've collected is a binary object, then we apply all of the signatures and heuristics to define what that file actually is. We have, as I said, 4,000 different file formats that we recognize today, and these file formats, you can think of them as document formats, your zips, your multimedia files. All of that is identified through signatures that we've created. Additionally, there are things which can't be identified with signatures, and in context of deploying software and creating software, that's really easy to understand. So programmers write code, and that code is usually in a textual file. And there's many different ways to write that code, and that's why creating a signature is really, really hard. So instead, we create machine learning models which discern from regular text, just descriptions and readmes, and also programming languages like Perl and PHP and Python and so on. Once we know what something is, then we start processing that file. So that's the next step. And processing is that static analysis engine component which for given format that we already identified applies parsing and processing and extraction methods. So just processing. So if the file contains other files within it, they are also going to be extracted during this step. So we're going to extract and create more content. But while we're doing this processing, we're also collecting additional metadata. That metadata describes the files we see, describes all the properties of these files. So if this is an email, typical properties would be here's the sender, here's the receiver, here's the subject, and so on and so forth. And depending on the file format, we today collect about 3,000 metadata points about these files. Some of them are easy to understand, as I mentioned, email, but some of them are really format specific. So we'd have function names and digital certificates and all those things. The cool bit about our technology is that there's many different ways to do certificates, for example. But what our platform does, it does metadata normalization, which means that regardless of what certificate type was used, the metadata is always going to look the same. And that enables us to create rules on the metadata, that enables us to create searches on this metadata and to correlate the metadata itself. But it doesn't stop there, right? Collecting the metadata is great, but what do you do with it next, right? So you need to transform. So you need to transform it. The metadata transformation goes from this raw metadata, which typically programmers and really good threat analysts and people like that would dig in deep and understand. But the metadata transformation tries to simplify what you're actually seeing. It goes from raw metadata to human readable indicators. And that's where an analyst can go in and understand all of the intricate complexities of what the actual file is trying to do. You can think of those indicators as human readable descriptions of intent. So what is the actual file trying to do? So after transformation, we do validation. We need to make sure that the metadata is valid. So validation of the metadata and the file content helps us to understand if the file format we identified is according to spec. So if here we identify the zip file or an email message, here we validate that in fact, it's been structured properly. The reason why that is important is because at that point we can detect if something is out of the ordinary and if somebody is trying to malform a file to create an exploit, right? It's trying to misuse whoever's opening, whichever program is opening this particular file and run arbitrary code upon it. And that gets us to the next step, which is really, really important, and that's classification. Classify, right? So we need to make sure that all of the data we have collected can be used to discern if the file is good or bad. And that's what classification is all about. So classification is just a term. There's many different ways to do classification. And there's about 12 different engines within our static analysis engine that actually do classification. We'll go into how we actually do it a little bit later. But what's important is that we have 12 offline engines which are using all this data collected so far to do classification. Additionally, through file intelligence or file reputation, we bring in fresh data from the cloud to make sure that everything we collected so far is not misused by malicious files themselves. So here we enrich the classification processes by using file reputation from the cloud. And finally, as kind of like a third step, there are YAR rules which users themselves can add to the platform. And this is what we call a user-assisted classification. The users can add rules which enrich the classification, and they fit nicely into this whole classification pipeline because the users have the option to name the threats themselves. If the file is classified through a YAR rule, it will appear as if one of our 12 engines has actually detected it. So the same naming standard, the same threat levels, they're perfectly compatible, but extendable by the user. So once we have all these data points, we make a decision. Is the file good or bad? And that's the ultimate classification that we provide. So once all of this is done, we've basically stopped. We've processed the file from start to finish. And as we've extracted files in this step, then we have to do the exact same thing for the next file. So this is file processing pipeline. So to just go through this loop yet again, so we started with acquiring the files, whatever they may be. We identified the file formats. We started extraction from those files. We collected the metadata. We transformed it. We validated it. We did classifications. We augmented those classifications with user rules, ultimately deciding if the file is good or bad, and then going through the exact same process for every single file that we extract. And that's what file processing pipeline is.